So, let's talk about traveling to the stars. What if I told you that the whole idea of building faster and faster rockets is completely wrong? Today, we are diving deep into a really radical theoretical paper by a physicist named Rolando Garcia. He proposes a blueprint for interstellar travel that doesn't just bend the rules, it throws the entire rulebook out the window. So let's get into it.
The paper opens with this statement, and wow, it really sets the tone, doesn't it? This isn't just some poetic flair, it's the entire thesis. Garcia is basically saying we've been asking the wrong questions about space travel, and the first step is to completely reframe what we think the problem is.
Okay, here's our game plan for this explainer. We're going to start with the massive problem that keeps us stuck here on Earth. Then we'll get into the wild new idea that reality is just an address. We'll look at how you could power this whole thing from the vacuum of space, then check out the quantum drive itself. And finally, and this is the most important part, we'll see how you could actually test this incredible theory.
First up, let's really get our heads around the challenge. Why do people say interstellar travel is pretty much impossible right now? Well, it all comes down to a problem of just unimaginable scale. 70,000 years. Let that sink in for a second. With our fastest current technology, that's roughly how long it would take to get to our closest stellar neighbor, Alpha Centauri. I mean, that's not just a long time. That's longer than all of recorded human history. It's a non-starter. And this is where Garcia's argument really clicks into place. He says we're stuck in a moving stuff paradigm. We're trying to solve the problem by building a faster horse, when the real breakthrough is something completely different, like inventing the internet. The issue isn't our velocity, it's our entire philosophy of what travel even is.
So if going faster isn't the answer, what is? This is where we get to the core of the axiomatic selection model, and I gotta tell you, it is a complete paradigm shift in how we think about the universe.
This slide just lays it out so clearly. On the left, you've got our current thinking. You take a physical thing, you push it really hard with rockets, and you make it cross a vast distance. But on the right, you have Garcia's model. The starship isn't a physical object. It's a set of information. You don't push it, you readdress it. It's a fundamental leap from physical transportation to informational reactualization.
For any of this to make sense, Garcia introduces a concept he calls the plenum. Now just think of the universe as a kind of operating system. The plenum is the underlying computational level, like the RAM, from which our physical reality is constantly being rendered. So your location in space isn't fixed, it's just a variable, an address inside this deeper medium.
Right. An idea this huge is going to need an equally huge power source. I mean, where in the world do you get the energy to literally rewrite a location in space-time? Well, Garcia's answer is just as radical as the theory itself. You get it from nothing, from the vacuum of empty space. And this is the key piece of hardware he proposes. We know that the quantum vacuum is seething with a tremendous amount of energy, but it's notoriously hard to get at. Garcia suggests building the special lattice from co-doped graphene, shaped like a fractal antenna. Now, why a fractal? Because vacuum energy fluctuates at every single scale at once. A fractal, with its repeating patterns at all scales, is theoretically the perfect shape to resonate with it and pull that energy right out of the void.
So how's it supposed to work? Well, the paper outlines a specific process called the plasmonic cascade. You start by hitting the lattice with a relatively low-energy terahertz wave. The fractal structure then takes that wave's energy and instead of changing its frequency, it compresses its spatial wavelength like crazy, converting the energy into something called plasmon modes. You're basically squeezing all that energy into an unbelievably small space, creating a colossal spike in local energy density.
And this energy spike has a very specific purpose. The math in the paper suggests that if you can pack more than 1 billion joules into a single cubic meter, you hit a theoretical threshold. This is the point where you could, in theory, create and stabilize a topological transition in space-time itself.
Okay, so we have a theoretical power source that's off the charts. Now let's look at the drive system itself. How would you actually use this energy to readdress a spaceship to a whole other star system?
Now this part is absolutely crucial. If you're going to deactualize and reactualize something as complex as a human being, how do you make sure you come back out, the same? The proposed answer is a structural fidelity buffer. Think of it as a shell of quantum entanglement that holds a perfect, protected, authoritative copy of your entire information pattern during the jump. So here's the whole process in 4 steps. First, you send a regular, slow probe to your destination to set up an entanglement hook. Then, back on your ship, the fractal lattice powers up.
creating that pinch point in spacetime. Third, you sync up with the buffer, which makes a perfect copy of your ship's entire biological and structural pattern. And finally, the axiom shift. The system resets your address in the plenum, and your ship's entire quantum wave function just relocates. You didn't travel there, you were readdressed.
I know what you're thinking. This all sounds like straight-up science fiction. But here's the kicker, and it's maybe the most important part of the paper. The claim that these ideas aren't just philosophy. They're supposedly grounded in real, falsifiable experiments that we could do.
Which brings us to the single most important question you can ask of any brand new theory, especially one this out there. How on earth do you even begin to prove something so radical?
Garcia actually lays out a concrete two-step plan. First, a kind of brute force test. You blast the lattice with that terahertz wave and use X-rays to see if it physically strains, if it actually bends, by the massive amount the theory predicts. If that doesn't show anything, there's a much more sensitive approach using delicate quantum sensors to hunt for the exact same effect, even if it's thousands of times weaker than expected.
And here's the thing that makes this actual science. The theory can be proven wrong. This table shows how each core claim has a clear failure condition. If the lattice doesn't resonate in the right frequency band, the theory's broken. If the X-ray test shows no significant strain, the core mechanism is wrong. If the supersensitive quantum test detects absolutely nothing after running for 2 hours, the theory is wrong. This isn't asking for faith. It's a scientific proposal with its neck on the line.
And that really is the bottom line of this whole thing. Garcia isn't asking anyone to just believe him. He's providing a detailed engineering blueprint and basically challenging the scientific community, saying, go ahead, run the experiments, prove me wrong.
We'll end with this last quote because it just perfectly captures the whole mind-bending shift at the heart of this model. So is this a real blueprint for reaching the stars, or is it just a fascinating dead end? The paper argues that the only way to find out is to build the experiment and ask the universe directly, which leaves us with the final question. Not just can we test it, but should we?